Okay. Hey, everyone. Yep. Yeah, give me a second. Okay, do you still see my screen? Okay. Great. I can only see my slides, so we'll go with this. Cool. So, hi everyone. I'm Tim Beiko. I work with the Ethereum Foundation, facilitating the Alcor Devs calls, and I'm here today to give a kind of historical overview of EIP-1559. So I'll go over kind of how it came to be, how we implemented it and got it ready for Mainnet, and how it might evolve in the future. And I have some transitions that I forgot to take out. But yeah, if you want to get these slides, you can get them at bit.ly/etc-1559. So apologies in advance, it's going to be heavy transitions between slides. So at a high level, EIP-1559's goal is to move the Ethereum fee market away from first price auctions because it's known that these are economically inefficient. The way that it does that is it specifies what's the minimum amount you need to pay for a transaction in every block, and we call that minimum amount a base fee. And what we do is we basically raise or lower this base fee based on how much demand there is for block space. So in order to gauge the demand on the network, we'll double the block size after EIP-1559 and allow blocks to be up to basically 200% full. And when they're more than 100% full, then we start raising the minimum price. And one thing that's nice as a side effect of that is that blocks on average will always have extra capacity, so it will result in better transaction inclusion guarantees. One other well-known fact about 1559 is it obviously burns the base fee to prevent miners from manipulating it either low or high. And this results kind of in a nice feedback loop because the more people use Ethereum, the more ETH gets burned. So it's like more demand for the network results in more of a pressure on the supply side. But the goal of my talk today is not to give a full overview of 1559 and how this works. There's a bunch of other talks and resources that do that. So I've linked a couple here for people who might not be as familiar. But yeah, the rest of this will be less about the EIP itself and more about kind of the process surrounding it. So if we look at kind of the prehistory of 1559, the first time something like this was mentioned that I could find is in 2016 on the Ethereum Foundation blog in a post by Vitalik, where he mentions that we could achieve kind of the transaction fee regime that we want if we determine a protocol minimum fee that transactions must pay and have the protocol take away the rest, which is pretty close to how 1559 works today, with basically having the base fee and burning that. So there was already kind of a hint at that. Then 2 years later, Vitalik made an ETH research post about first price versus second price auctions and blockchains, and actually kind of wrote down what the kind of mechanism by which you could update the base fee under 1559. So those were all kind of really early posts in the history. And then about a month after that, in August 2018, Vitalik actually opened a GitHub issue against Zcash, proposing that they evaluate EIP-1559 as a transaction fee mechanism for that network. And the text of that proposal is pretty close to the actual EIP-1559 text. But then basically 2 months, or no, sorry, more like 4 months after that, EIP-1559 was properly opened against the Ethereum EIP's repo, and that's what it got its name. It stayed dormant for a few months until basically in March 2019, Eric Connor kicked off a discussion about it on Ethereum Magicians, asking if it could be considered for the next network upgrade. there was a lot of back and forth about it, and it led to people realizing they would want to have this in an upgrade, but we'd need to prototype it extensively first. So that's when the Vulcanize team started to work on it. And this was also kind of the first time where some of the core developers, so specifically the Get team, raised some concerns about the denial of service risks from EIP-1559. Yeah. But basically, the Vulcanize team went along. The first thing they did was actually to commission an implementation study to analyze the EIP, what changes would be required in Geth, how we could actually deploy it to Mainnet. And they came up with this 2 fork approaches, which would deploy the EIP on the network in 2 stages. The first fork would add a new transaction type for EIP-1559 transactions, and then have those run in parallel to legacy transactions. There's a typo on my slide. And then this, at the same time as you've added this new transaction type, you would add a transition function where over time you just reduce how much gas you have available for old transaction types. So that would basically force people to upgrade, because even though transactions that were not 1559 style transactions would still be valid on the network, at some point there would just be no more gas in a block available for them. And then you'd have a second fork, which would basically kind of clean up and do a lot of refactors, but also basically give the full block space for 1559 style transactions, so we could then deprecate the legacy ones. So that was the original way we planned to go about it. And what was nice about this is it was kind of a stick and carrot approach, where on one hand, the reducing block size is an incentive to stop using legacy transactions. And the other idea that was proposed by Vulcanize is that you could have gas cost reductions only ever happen on 1559 style transactions. So that means you'd also have an incentive to switch to them early on. So around February, Vulcanize opened a pull request against the Get code base for a proof of concept, basically, of this approach. Then 2 years ago now, at ETHCC in 2020, which was March 2020, there was some conversations about EIP-1559, and especially at the time we were talking a lot about stateless Ethereum and how we could get that on the roadmap. And it felt like 1559 was something that was far enough that we could try and get it out before stateless Ethereum. So that's when the idea of having kind of a working group dedicated on actually getting this from a proof of concept to something that's ready for Mainnet came together. So in April 2020, 1 month after ETC, we had our first 1559 contributor call. Our goal was to get 1559 on Mainnet by end of 2020. This obviously didn't happen. And at that time, the Beiko team, which I was a part of then, started working on an implementation as well to go alongside the Get one. Then later that spring, we spent a lot of time looking at different designs for EIP-1559 and different models that it could look like. The main one was Dan Finlay's escalator fee proposal, which would say, instead of 1559, where you specify kind of the minimum price in the network and then an optional tip for the miners, Dan's proposal would have you specify kind of the amount of time you wanted your transaction to be valid for. So from 1 to 10 blocks, and the amount that you're willing to pay. So say up to 10 gwei, and then it would just escalate your bid over time. So say you're willing to wait over 10 blocks and pay 10 gwei, then you would bid 1 gwei in the first block, 2 gwei in the second, and so on. And so that would give users a lot of granularity about how they could submit the transactions. So MetaMask made some mockups for both options, which you can see here. So on the left side, you had the 1559 approach, and on the right side, you had the escalator fee proposal. In the end, we decided to not go with the escalator fee after considering a lot of designs. One of the main reasons for this was it added a bit of complexity, but it's also something that was possible to do outside of the core protocol. So a wallet could just do this on your behalf. There's a bit of extra overhead in resubmitting all those transactions. But still, we decided that it was better to keep 1559 as simple as possible and to potentially implement something like escalator fees at the wallet level and not in the core protocol. After this, around June, we started realizing this would be a pretty big effort. It would require not only implementers from all the different teams, but also some research, some prototyping and whatnot. So we put together a Gitcoin grant to pay for this. We were very, I guess, lucky in that we raised the largest amount on Gitcoin up to that point for over $100,000. We got, I think, was also the largest number of individual donors to a grant on Gitcoin. So that was like a really big success, and it gave us the funds that we needed to basically cover most of the work that wasn't already being done by either Consensus or the Ethereum Foundation. And by the end of the summer, in August, we had this Mainnet readiness checklist, which basically had a list of all of the open issues that we still had with the EIP. So the stuff that was basically stopping it from being ready for Mainnet. So things like actually managing how the transaction pool sorting would work. How do we deal with things that were introduced in Berlin, like EIP-1559 and whatnot. So we just started working through all of these issues on our list. And then in September 2020, a lot of people were starting to ask when 1559 would be ready. So we started put together these updates on EIP-1559 so that the community could kind of keep track of the progress. About a month after that, we solved one of the biggest technical problems we had left. So one big thing that we wanted to avoid at this point was this kind of too hard fork approach that was initially proposed by Vulcanize. We felt it would be much cleaner if we could just do everything at once. But the one big challenge there was, how do you keep supporting legacy transactions? And also, how do you not have two different transaction pools, one for legacy and one for 1559 transactions? The original implementations all had that. So in October, we figured out a way where if you send a legacy transactions, we could literally interpret it as a 1559 one, where your gas price is equal to your base fee and it's equal to your tip. What's nice about this is that it makes it very easy to send legacy transactions, and it basically makes EIP-1559 support optional. So if a wallet doesn't want to support it, the network can always support legacy transactions. But it also gives an incentive to support 1559, where when you send a legacy transaction, basically the entire difference between the current base fee and your gas price would go to the miner. Whereas when you send a 1559 transaction, you can specify exactly how much you want the miner to get. And get a refund for any excess fee you have. So it's slightly more kind of gas efficient to send a 1559 transaction. But if what you're worried about is backwards compatibility, then you can always send a legacy transaction, which is really nice. About a month after that, we started launching, we called the 1559 Toolbox, but just a set of APIs and JSON RPC endpoints for people to actually start interacting with 1559 on a development network that we had. And finally, around the end of the year, we had Tim Roughgarden publish a 50-page economic analysis of 1559. This was really good because up to then we didn't have kind of a formal paper that walked through the mechanism and tried to explain why it was actually better than today. So Tim Roughgarden did like an excellent job of articulating that. It convinced some of the kind of most vocal skeptics that were still remaining, who didn't think 1559 would necessarily work as expected. And then we started wrapping up at the beginning of this year on the implementation side. So around January, we had our last official 1559 focused call The Quilt team came up with a way that we could do transaction pool management very efficiently. We also decided to create a separate EIP for a base fee opcode so that smart contracts could access this. And Vitalik published some analyses around these denial of service risks that we mentioned at the very beginning, saying that after Berlin, he thinks these would be fine. And people agreed with him on that. And finally, the last thing we needed to test was whether we could have a network which had a large state handle blocks that were 200% full for a long period of time. So we built an entire tool that would generate a network from scratch with a state basically as large as Mainnet, and that we could spam this with transactions for hours on end to see whether the network would fall behind. And after a few kind of hiccups with the initial tests, we managed to get it all up and running and show that it was good. So this really kind of helped our confidence before pushing it to the public networks that the actual client implementations could support 1559. So then we were finally ready to get it accepted into a network upgrade. So in March 2021, a year after we kind of started this working group, which was already kind of 6 months after the initial proof of concept started, EIP-1559 got accepted for the London hard fork, which is expected to go live early August this year. We basically got it implemented in all of the clients. We got it deployed across the other EIPs that are going into London, across in the client integration testnets. And the spring, as kind of the work in the clients was wrapping up, we started having more community calls with wallets, infrastructure providers, and whatnot to help them add 1559 support. And then in June, 1559 was announced to go live on the testnets. It did. And finally, in July, just last week, we scheduled the mainnet fork for August 4th, roughly, or block 12,965,000. So this kind of shows kind of how long of a process it was to get 1559 from an initial idea to then an EIP to a proof of concept to something we thought was viable to ship on mainnet to then tested, deployed on the test nets, and now scheduled for mainnet. Looking forward, there's a few things that we'll want to do with regards to EIP 1559. The first is just collecting metrics once it goes live. So we'll be able to see kind of the average gas prices paid, the variance about that in a block and whatnot, and quantify kind of is 1559 truly better in terms of pricing transactions than our current model, and if so, by how much. One small change we might want to do in the future is kind of symmetric base fee updates. So right now the base fee gets updated by 1/8 to the maximum, either to the upside or the downside. But that means if you go up to a large number, the actual amount that it gets updated by is smaller than when you start going down, because you basically take the 1/8 from the previous block. So that means that the base fee is kind of quicker to go down than it is to go up. So that's something that's kind of a small fix we might update in the future. Obviously, once the merge happens, we'll just have to kind of reroute transaction fees from going to validators rather than going to miners. And finally, oh, there's another typo here, but the data sharding, so when we deploy shards on Ethereum 2, we'll also use a 1559 type mechanism to price the cost of storing data on those shards. So that's all I had. Again, if you want these slides, you can find them at bit.ly/1559. I'm not sure if there is the time or a way for questions, but if so, I'm happy to take them. Yeah, great question. So I'm aware that MetaMask and MyCrypto have been working on adding support for it, and they both plan to be ready for August 4th. I'm not 100% sure about the other wallets. I know also there's an open pull request against the Trezor hardware wallet. They don't think they'll be ready for August. They're just going to have a firmware updated in September. So those three are the ones I'm aware of. Like I mentioned, also, like if your wallet doesn't support it, it's not the end of the world at first. Yeah, but I know that MetaMask and MyCrypto are trying hard to add support for it. Yeah. So definitely, like in the next year, I don't see it going away. One thing we did in Berlin, we introduced the EIP 2718, which is kind of a transaction type wrapper, which allows us to create kind of more transaction formats. And there's, there was an EIP that added a new transaction format in Berlin with access lists. Now we have these 1559 transactions, and there's more EIPs that are kind of looking at different transaction types. So I suspect we probably go to a world where, like, we're likelier to have like 5 to 10 transaction types than to have just one or two. So if there was ever a reason to deprecate legacy transactions, maybe we could do it. But it's more likely we just end up in a spot where we support many more. The thing that's hard about deprecating transactions is always like, what if somebody signed a transaction 2 years ago, and for some reason they can't like re-sign it or whatever, and they were planning to deploy it on the network in 2 years, and then they realize that they can't. So you're always kind of scared that you block somebody out. Cool. Cool. Thanks, everybody.